Hello everyone. This is our first lecture for Chapter 3 on the normal curve and normal distributions. This chapter introduces the concept of a bell-shaped or normal distribution and its graph, the normal curve. Most of the statistical analyses in this class are based on normal distributions. We will define what it means to be normal and present some important characteristics of normal distributions and curves. We will also discuss the empirical rule. Here are the learning objectives for Chapter 3. This is what we are going to go over, and this is what you will need to know for the next proctored quiz. Think of these learning objectives as your roadmap through the chapter and your study guide for the quiz. Take a minute, hit the pause button, and go ahead and read through these. In this lecture video, we will discuss normal distributions, its curves, and their characteristics, and we will also introduce the empirical rule. When data sets are graphed, they form a picture that can help us in the interpretation of the information. The shape of a distribution provides us with information about how the data are dispersed, or how spread out the data are. As you can see on this slide, distributions can take on many different shapes, and each shape gives us different information about the data it represents. The most common type of distribution is called a normal distribution, which creates a normal curve, or what is often referred to as the bell-shaped curve because it looks like a bell. A normal distribution is symmetrical. This means that the distribution and frequency of scores on the left side matches the distribution and frequency of scores on the right side. Here is a graphical representation of a normal distribution. It's a bell-shaped curve, symmetric, and unimodal. Many distributions fall on a normal curve, especially when large samples or data are gathered. These normal distributions include height, weight, IQ, SAT scores, blood pressure, and so on. This is important to understand because if a distribution is normal or bell-shaped, there are certain characteristics that are consistent and help us to quickly understand the scores within the distribution. In a distribution of data, most of our scores will be clustered around the middle of the distribution, with a few of our scores out towards the tails. This also tells us the probability of selecting a given score by chance. If we were to pick a score at random from the distribution, we would be more likely to get a score that is closer to the middle or the mean than out towards the tails where there are fewer scores. Most of our scores will be near the middle in what we call the average range. Remember, for any distribution, the mode represents the high point of the graph, the median represents the point where 50% of the area under the distribution or curve is to the left, and 50% of the area under the distribution or curve is to the right. The mean represents the balancing point of the graph of the distribution. For symmetric distributions or normal distributions, the mean, median, and mode are approximately the same. So usually, the mean equals the median equals the mode. In Chapter 2, we discussed skewed distributions. Remember that the skew refers to which direction the tail is pulled into. When a curve has extreme scores on the right-hand side of the distribution, it is positively skewed. In other words, when high scores are added to an otherwise normal distribution, the curve gets pulled in a positive direction or to the right. When the curve is pulled in a negative direction or to the left by extreme low scores, it is negatively skewed. The more skewed a distribution is, the more difficult it is to interpret. Here is just a graphical representation of how the mean, median, and mode in a normal distribution divide the curve exactly in half. As you can see on this slide, 50% of the scores are below or to the left of the mean, median, and mode, and 50% of the scores are above or to the right of the mean, median, and mode. Remember, if a distribution is normal or bell-shaped, there are certain characteristics that are consistent and will help us to quickly understand the scores within that distribution. The characteristics of a normal curve are as follows. 1. It is symmetric around its mean, mu. 2. Because the mean, median, and mode are approximately equal to each other, the highest point occurs at x equal to mu. 3. The area under the curve is always equal to 1. And 4. 50% of our scores fall to the left of mu or below mu, and 50% of our scores fall to the right of mu or above mu. The data in a normal curve are distributed or spread out according to a rule known as the empirical rule. The empirical rule is a very useful and important rule that is used in statistics and probability to make rough estimates about the data. The empirical rule states that approximately 68% of the data will fall within one standard deviation of the mean, plus or minus 1 sigma. Approximately 95% of the data will fall within 2 standard deviations of the mean, plus or minus 2 sigma. And finally, approximately 99.7% of the data will fall within 3 standard deviations of the mean, plus or minus 3 sigma. This means that it would be very unusual for a score to fall more than 3 standard deviations from the mean. Typically, in the behavior sciences, any score that falls more than 2 standard deviations from the mean would be considered outliers. Here is a graphical representation of the empirical rule. Let me add that 50% of the data will fall below the mean and 50% will fall above the mean. This rule gives us a quick rough estimate of how spread out the data are for a normal distribution based on its mean and standard deviation. So now let's look at a quick example on how this actually works. So let's suppose that the pulse rates of 1,000 college males are normally distributed or bell-shaped with a mean of mu equal to 72 and a standard deviation of sigma equal to 6. Using the empirical rule, we can estimate that about 68% of the males have pulse rates between 72 plus or minus 1 times 6, or specifically 68 to 78 pulse rates. About 95% of the males have pulse rates between 72 plus or minus 2 times 6, or more specifically, about 95% of the males have pulse rates between 60 to 84. And finally, about 99.7% of the males have pulse rates between 72 plus or minus 3 times 6, or about 99.7% of the males have pulse rates between 54 to 90. In our next video, I will introduce Z-scores.